Yeah.
Namaste,
Yeah.
Swamiji. Ishwari, you can start.
Yes, sir. A very good evening to one and all present here for the AICT ATAL FDP on a Boulevard to Neoteric Geotechnical Engineering. Our secretary, Dr. K.S. Babai, is one of the senior most educationalists in the country and a prominent civil engineer. Under her leadership and guidance, our institution, Meenakshi Sundararajan Engineering College, and the Department of Civil Engineering has conducted fabulous events like ECube, Enrichment, Empowerment, and Enhancement, and SBI, Societal Beneficial Innovation, for the students to create awareness in the young minds about research and innovation. These terms, eCube and SBI, were coined by our Secretary Madam. Following her vision, we have assembled today, this evening, to participate in this excellent event, the AICTE ATAL FDP on a Boulevard to Neoteric Geotechnical Engineering. A day without prayer is a day without blessing. To begin with, let us first invoke the blessings of the Almighty. I request Ms. Ramya of first year CSE to sing the prayer song, following which our college song will be played.
गजानना गजानना गौरीनन्दना शिवनन्दन गजवदना गिरिजनन्दना हे गौरीनन्दना गिरिजनन्दना देवाय शुद्धाय बुद्धिव्रताय देवाय शुद्धाय बुद्धिव्रताय ध्वजप्रियाय दयायुतय विघ्नेश्वराय ध्वजप्रियाय दयायुतय विघ्नेश्वराय गौरीनन्दना गिरिजनन्दना एकदन्तलम्बोदरा एकदन्तलम्बोदरा श्रीगणनाथा मूषिकवाहन मोहन प्रिया प्रणवाकारा गौरीनन्दना गिरिजनन्दना गौरीनन्दना गिरिजनन्दना 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 गिरिजनन्दना
जयतु मीनाक्षी सुन्दर राजयन्त्र विद्याशाला जयतु मीनाक्षी सुन्दर राजयन्त्र विद्याशाला शृङ्गेरी श्री भारती कीर्तयति कृताशिषा शृङ्गेरी श्री भारती कीर्तयति कृताशिषा श्री शारदा कृपा पात्रवंश परम्परया सुसंवर्ध्यमान श्री शारदा कृपा पात्रवंश परम्परया सुसंवर्ध्यमान कलियुग कर्ण सुन्दर राजेन समारब्धा कलियुग कर्ण सुन्दर राजेन समारब्धा सिद्ध
It gives me immense pleasure to welcome all the dignitaries, our distinguished guest, Dr. Krishna R. Reddy, Professor, University of Illinois, Chicago, our beloved Secretary, Dr. K.S. Babai, Madam, Swamiji from Ramakrishna Mutt, our Principal, Dr. P.K. Suresh, Sir, our Dean and Head of Civil Engineering Department, Dr. L. Ramajam, Sir, our FDP Coordinator, Dr. R. Arivalagan, Sir, participants, faculty members, research scholars, students, industrialists, my dear friends and colleagues. I once again welcome you all to the online faculty development program on a Bollywood to Neoteric Geotechnical Engineering. I feel overwhelmed to introduce the distinguished speaker of this evening, Dr. Krishna R. Reddy. PPT. Dr. Krishna R. Reddy is University Scholar, Distinguished Researcher, and Professor of Civil and Environmental Engineering, the Director of both Sustainable Engineering Research Laboratory and the Geotechnical and Geoenvironmental Engineering Laboratory in the Department of Civil, Materials, Environmental Engineering at the University of Illinois at Chicago. Sir received PhD in Civil Engineering from the Illinois Institute of Technology, Chicago. He received gold medals for being first in both BS Civil Engineering at Osmani University, India, and MS Civil Engineering at the Indian Institute of Technology, Roorkee. Sir has over 28 years of research, teaching, and consulting experience within the broad fields of civil, geotechnical, materials, environmental, sustainable, resilient engineering, addressing the nexus among sustainability, resiliency, infrastructure, water, energy, and the environment. He has authored 284 journal papers, 32 edited books, conference proceedings, 25 book chapters, 235 full conference papers with H-index of 70 and over 17,000 citations. Sir has given 290 invited presentations in the USA and 21 other countries. His research expertise includes environmental remediation of soils, sediments, groundwater, and stormwater, solid and hazardous waste management, waste containment and landfill engineering, characterization and engineering applications of waste recycled materials, life cycle assessment, and sustainable resilient engineering, and geotechnical engineering. His research is funded by US National Science Foundation, US Environmental Protection Agency, several prominent state and local government agencies and industries. His research includes laboratory studies, field experiments, computer modeling, ultimately leading to fundamental advances and practical solutions to the real world problems. Sir has served or currently serving as an associate editor and editorial board member for over 10 different journals, including ASCE Journal of Geotechnical and Geoenvironmental Engineering, ASTM Geotechnical Testing Journal, ASCE Journal of Hazardous Toxic and Radioactive Waste, Journal of Hazardous Materials, among others. He has also served on various professional committees, including the Geoenvironmental Engineering Committee and Technical Coordinating Council of GeoInstitute of the American Society of Civil Engineers and the Environmental Geotechnics Committee of International Society of Soil Mechanics and Geotechnical Engineering. Sir has received several awards for excellence in research and teaching, including Fulbright US Scholar Award, ASC Wesley W. Honor Award, ASTM Hogan Togler Award, UIC Distinguished Researcher Award, University of Illinois Scholar Award, and University of Illinois Award for Excellence in Teaching. He is a Fellow of the American Society of Civil Engineers, a Diplomat of Geotechnical Engineering, a Board Certified Environmental Engineer. He is also a Registered Professional Civil Engineer and an Envision Sustainability Professional. We are extremely honored to have such a renowned academician and researcher among us this evening to enlighten us with his knowledge and expertise. Now I request our principal, Dr. P.K. Suresh, sir, to do the felicitation.
Sri Gurubhyo Namaha. Sri Gurubhyo Namaha. Viveganam Mahapratyam Tej Audarya Kshamadanim Sada Abhinavapurvandam Vidyatirtha Gurumati. Honorable Secretary, most respected Professor Krishna Reddy, energetic Arivalagan, my dear faculty members, it is a very great honor to welcome you all in this beautiful session. And we are entering the neoteric chapter in geotechnical engineering. This, when I was studying geotechnical thing, it was a classical geotechnical. Now, a lot of neoteric things have come. I am very happy, and just I want to put a few words about this college. This college had its origins in 1947 by Professor K.R. Sundararajan, and he has started an Indian Institute of Engineering Technology, which was giving AMI coaching center to all to the students throughout the country. Later on, the first women's college in the state has come in 1975 in this campus. And this Meenakshi Sundarajan Engineering College was started in the year 2001. And subsequently, we had Meenakshi School of Management also. And I want to say one thing, this college is totally guided by the Sringeri Jagadguru Shankaracharya, and under his guidance, we are moving forward. And with his blessings, we are conducting all these things. And I once again welcome you all and wish you all a very happy time. I am now right now in Chandigarh in the mid cold, so I am sorry that I couldn't come. And we will be meeting in person the last week during the offline session. I once again thank the eminent Professor Krishna Reddy for giving his accent to give the lecture today. And sir, really, we are really honored to hear from you. Only you should help the institute like us. Then only we have got a lot of good students. It entirely, this is a Vidya Dhanam you are doing, which is almost equivalent to Annadhanam. I once again thank you. Wish you all. Thank you.
Thank you, sir. Now I request Swami Apavargananda from Ramakrishna Math to give his blessings.
பொறியியல் பேராசிரியர்களுக்காக 14 நாட்கள் நடக்க இருக்கும் இந்த ஒரு மகத்தான கருத்தரங்கு வெற்றிகரமாக அமைய பகவான் ஸ்ரீ ராமகிருஷ்ணர், அன்னை சாரதா தேவி, சுவாமி விவேகானந்தர் ஆகியோரிடம் பிரார்த்தனை செய்கிறேன். இந்த அமர்வில் குழுமிருக்கின்ற திரு கிருஷ்ணா ரெட்டி அவர்களுக்கும், பி.கே. சுரேஷ் அவர்களுக்கும், பாபி மேடம் அவர்களுக்கும் மற்றும் இங்கே குழுமிருக்கின்ற பேராசிரியர்கள் அனைவருக்கும் தெய்வ திருமூரின் இன்னருள் பெருக பிரார்த்திக்கிறேன். இந்த நிகழ்ச்சியில் மூலம் கலந்து கொள்கின்ற அனைவருக்கும் ஒரு நல்ல ஒரு கருத்து பரிமாற்றமும், அவர்களின் செயல்களில் சிறந்து விளங்குகின்ற அந்த எழுச்சியும் வல்லமையும் கிடைக்கட்டும். அத்தகு அறிவு பரிமாற்றம் இங்கே நிகழ்ந்து எல்லாம் அல்ல இறைவனுடைய அருளால் நம்முடைய தேசமும் இந்த உலகமும் பயன்பெறட்டும் என்ற ஒரு பிரார்த்தனையோடு அமைகிறேன். நன்றி, வணக்கம். ஜெய் ராமகிருஷ்ணா.
Thank you, Swamiji. Next, I request Dr. L. Ramajam, Dean and Head of Civil Engineering Department, who has vast experience in the field of civil engineering, to share a few words and to address the gathering. I request Dr. R. Arivalagan, our ATAL FDP coordinator, to address about the FDP.
My heartfelt namaskaram to Swamiji, most respected Professor Krishna Reddy, our beloved Secretary Madam, our most respected Principal Dr. P.K. Suresh sir, our leader and guide Dr. L. Ramajam, HOD Dean Civil, my dear colleagues, my dear affiliate students, and all our fortunate participants in various universities, institutions and research centers, good evening to all. Today we are very honored because popular eminent Professor Dr. Krishna Reddy from Chicago with us. He is the person coined the term resilient engineering. As previous, we are familiar with sustainable engineering. Very long back, our great poet Thiruvallur mentioned about the consolidation method in Tirukkural as "Todipulidi kapsa unakin, பிடித்தெருவும் வேண்டாது சாலப்படும்." இதன் பொருள், ஒரு புலம் எடையுள்ள மண்ணை கால் பலம் ஆக்கும்படி உழுது காயவிட்டால் ஒரு பிடி எருவும் தேவையின்றி பயிர்கள் அந்த நிலத்தில் செழித்து வளரும். This concept was implemented recently by the CMRL for the construction of railway yard at Coimbatore, Chennai. The land selected for the yard was waterlogging land. This was improved by removing water from the soil using vertical drains to improve the soil to resist the moving train loads. This ground improvement technique was done within the short duration with the effective design methods. Now India has emerged as one of the fastest growing economies in the world. Geotechnical engineering is the first and most important aspect of any infra project and urban development. Over the years, many new trends were being developed and practiced in terms of analysis, design, and construction of geotechnical structures and associated site investigation. Generally, the foundation of the structure is buried in the soil. Because of that only, many of us are not worried about the geotechnical aspects of the structures. Many structural failures happened all over the world are mainly due to improper foundation designs. Even our recent Mohaliwakam building failure made an eye-open for us to better geotechnical designs. Our team, believes that this FTP will form a boulevard, that is the 16-track huge highway or path to travel for 2 weeks to reach a place of advanced, innovative, that is nutric, and recent techniques of the geotechnical engineering. AICTE framed this FTP for the maximum participants of 50, but we hope that 50 participants may transfer the knowledge that they gained from this program to our engineering students. This is the objective of our management and also AICTE. By the end of the 2 weeks faculty development program, each candidate who have partly effectively will get a knowledge on the different subdivisions such as site investigation and its citizen methods, ground improvement techniques, environmental applications, behavior of soil and soil deformation, underground structures and soil structure interaction problems, offshore structures, challenges in soil behavior due to earthquake and other natural disasters, construction methods in challenging situations, earth retaining structures and its needs, factors affecting foundation design, importance of finite element analysis in geotechnical engineering, etc. Moreover, India keeps on developing in the aspect of implementation of hydropower projects and underground structures. There is a need for students, academicians, and practicing professionals for updating their knowledge about the emerging trends in various geotechnical areas. This workshop presents some of the emerging trends in the geotechnical engineering practice and research activities. This will enhance the knowledge of the academicians to train the students to perform more research. தாம் இன்புறுவது உலகு இன்புறக் கண்டு காமுறுவர் கற்றறிந்தார். தான் கற்ற கல்வியால் தான் இன்புறுவதோடு அந்த கல்வியால் உலகத்தாரும் இன்புறுவதைக் கண்டு தான் அக்கல்வியை மென்மேலும் கற்று இன்புறுவர். So, our team, wish you all to make use of this FTP to enrich your knowledge and also to our students. Thank you. Jai Hind.
Thank you, sir. Next, I request our beloved Secretary, Madam, Dr. K.S. Babai, to inaugurate the FTP and deliver the inaugural address.
I'm really happy and proud that our civil engineering department, when I say our civil engineering department, I think everyone can understand I'm also a civil engineer only. So, in civil engineering, the FDP program, second time, if I'm correct, is being conducted. And I'm really proud of you. And the topic that is chosen is really very relevant to the present day advancement and what can I say, even research. That way I am very happy that kind of topic has been chosen. And to the guest lecture from Dr. Krishna Reddy from Chicago, I am proud to say that some of my old students studied and they were working also in Chicago. I don't remember the exact university, and they even got doctorate in from university from Chicago and master's program also. So I'm really happy that many of our students have gone all over the world, especially very well USA. They all like it, and they did the master's program and also they did the doctoral program. And they are settled there in universities and of course industries also. So that way, as we say in Tamil, Thiragadalodiyam Thiraviyam Thedu. According to that, they are ready to go anywhere in the world so that they can earn by working in a quality way. And regarding our staff members, as far as we know that our principal is a great research scholar, not only doing a lot of consultancy work. Similarly, the head of department and others in civil engineering department, they are also doing a lot of utility value research work, and it's really helpful to the society. Anyway, I am proud. And I went through one of your resume. I think if you are interested in a lot of that radioactive waste, my thesis is about radon-thoron concentration in many houses in and around Chennai. Therefore, when I saw it, really I felt happy. And of course, our Kalpakam, you might have heard that atomic research station. It helped me a lot for doing testing and getting the results, everything, because it is very difficult for us to have all the equipments, and they are having everything. It was easy. So that way, today, that kind of latest field we have to go. And learning for teachers is a continuous process. Even today, at this stage, I want to learn because that is good for us. Similarly, teachers, I'm really very happy. Many of you, I think more than 40, you have joined this forum. And for the betterment of the students, for the betterment of the future, every day we have to learn. And this FDP, I thank AICTE and central government for having accepted to conduct this. And it is also nice that 1 week it is online and 1 week offline. So 1 week online, great people like Dr. Krishna Reddy can join us because it is online. Otherwise, it may be difficult for him, but it should not be difficult because he has to come to India, and it is not difficult because again, where all he's traveled, I saw it. He really has covered the entire world geography. That's what I feel. There is no country or no city which he has not visited. Still, now he feels comfortable sitting in Chicago and attending this conference, delivering his lecture. And offline next week to the participants, I'll tell you, our civil department will take care of you not only learning and enriching your knowledge, also they may make you feel comfortable and feel happy that you visited a really a good institution. Best of luck to everyone, and I'm very happy to inaugurate such wonderful FTP program. My best wishes to all the teachers and the participants, of course, the great solvers like Dr. Krishna Reddy. Thank you once again.
Thank you, ma'am, for your wishes and always inspiring us in all our endeavors. Now I request our distinguished speaker, Dr. Krishna R. Reddy, Professor, University of Illinois, Chicago, to take over the session and enlighten us with his address on sustainability in geotechnical and geoenvironmental engineering.
Yeah, good evening, everyone. Good morning here. Let me share the screen and then. Let me know if you can see the presentation.
Yes, sir, we can. It's visible, sir. No.
Everything is okay? Yeah.
Yes, sir.
So, yeah, good evening, everyone. I'm very, very happy to be part of this faculty development program. I am, first of all, I want to congratulate, Meenakshi Sundarajan Engineering College for organizing this very interesting faculty development program. When I looked at the name of the program, I was a little bit fascinated, because it's not a typical title that I could see for FDP. The boulevard, of course, is a road or a pathway, but it's a beautiful pathway. A lot of times it's, I would say, sustainable, green, and enriching, and that kind of attracted my attention. And other word, neoteric, is again is a very new word. I'm not used to seeing that kind of word, but again, that represents the modern or emerging, cutting edge. So I think that also very clever in terms of choosing that word for this program. So I really, we are at a crossroads. I think we really go on a path where the geotechnical engineering can advance in a very significant manner, and make a huge difference in practice of civil engineering, and ultimately help the human quality of living, and also help the planet. So again, thanks for the opportunity to visit. I was in Chennai. I was at IIT Chennai this summer. I had an excellent time interacting with a lot of people in Chennai area, and also visiting other places in India. So first, before I get started, again, I want to thank the Department of Civil Engineering, Meenakshi Sundararajan Engineering College, Chennai, for conceiving and organizing this conference, organizing this faculty development program, and hopefully, it's a very good program. I saw first week is online and second week is offline. I think we have presentations on many different topics. I know a lot of speakers, so hopefully we will learn a lot of advancements in geotechnical infrastructure, geo-environmental protection, and sustainability and resiliency related topics. I also want to thank the organizer, Dr. Arye, Associate Professor, Department of Civil Engineering. I met him during my visit to IIT Madras. I know this program is being postponed, but ultimately it is happening. I know one date that was proposed, I was traveling overseas, but I'm glad it is postponed to today. I'm able to join and present in this FDP. I also want to congratulate all the organizing committee and the college administration for putting together and supporting these kind of programs. This is not like a typical conference. We are educating the educators, and as Madam Dr. Baba has mentioned, we are educating also the RA as alluded. We are educating educators, so that will expand the knowledge dissemination. So it's a very good program in terms of expanding the knowledge to the students, and AICTE for supporting these kind of programs. It's very, very interesting, very impactful, and all program participants for taking this opportunity to enlighten yourself and also enlighten your students in the future. So as you know, I'm from Chicago. Chicago is a beautiful place, and many of you know, at least from Swami Vivekananda's visit, many in India know where Chicago is, what Chicago is all about. But these are the pictures of what Chicago looks like now. And you see, it's beautiful, right? I mean, this is the testament to what civil engineers can do, in terms of civil infrastructure, at the same time protecting the environment, water, nature, that kind of stuff. So without civil engineering, we would not have the quality of life that we have, and also taking care of the planet. So you are welcome to visit Chicago next time. Whenever you come to US, please drop by Chicago. I will be happy to host you. And the last two pictures that you see here, we are just the west side of the downtown, and you can see our campus. The last two pictures are our campus, and our campus again is very much interested in sustainability, and all the projects that we do consider the sustainability aspects. So I am in charge of two labs, a Sustainable Engineering Research Lab and Geotechnical and Geoenvironmental Engineering Lab at my university. Just to give you an idea about the types of research that I do, I am more into environmental remediation of soils, sediments, groundwater, and stormwater, because you have a lot of this contamination, and it's posing risk to human health and the environment. So remediating these kind of problems is extremely important, and finding the technologies that can be done, that can be used to solve the problem. So that's part of my research. The other area for my research is waste management and landfill engineering. Again, there are a lot of issues dealing with the waste management. We are producing a lot of waste, and unless we do certain things, the problem is going to be uncontrolled. So there are a lot of ways we can beneficially use the materials, and we can do a lot of different things. Ultimately, if we have to have landfill, that needs to be well designed. So this is a huge problem in India, dump sites, and I cannot understand why we cannot solve these problems. We have expertise to solve these problems. Hopefully, they can be solved soon. The other area of research that I work is on life cycle assessment and sustainable and resilient engineering. This is a very important topic. It's a very emerging topic. It's not only relevant to geotechnical engineering, civil engineering, but any branch of branch of engineering. We really need to think about engineering to achieve sustainability and resiliency. So this is the topic that I chose to present during this FDP, because this is a new topic and there is a lot of scope to do a lot of innovative research, and also teach our students to be prepared to address these issues into the future. So my master's and PhD is geotechnical engineering. I am familiar with a lot of things that are going on in classical geotechnical engineering, but my undergraduate degree is in civil engineering. As you see, I have a civil engineering degree and then geotechnical engineering degree, but I have expanded my expertise into solving the real world problems. That's how I got into this geo-environmental engineering topics, because I know a lot of people are working on geotechnical engineering and a lot of things are established, but in geo-environmental side, people are not, environmental engineering, people are not able to do certain things with a geotechnical background, some additional environmental background. You can do a lot of these solve these important problems. And the sustainability is an extremely important issue. So everybody should be working on it now. So I have a pleasure of working with a lot of research students and scholars from all over the world. Obviously, I have a lot of students from India. I welcome, students from your college if they are interested in master's and PhD. These are the students who have done actually research projects with me, master's thesis or PhD with me. So it's always fun to work with. I tell people that I have the best job in the world being a teacher. I'm able to interact with talented students from all over the world, not only doing the technical stuff, but getting to know them personally in terms of their culture, in terms of their language, personalities. So, life is more than technical stuff. So it's human interaction is extremely important. So I tell people that the best place for me to be happy is in my lab. So whatever we have done over last 25 years, that work has been summarized in these 4 books, and also many journal papers and conference papers. I highly recommend you to go to this website. That's my lab website, where you can download a lot of papers, conference papers, and information on these books. So you will have an idea about all these different topics and what kind of research we have been doing over the last 25 years. So let's come to the presentation. Based on the audience and based on the discussion with the organizers, first I'm going to talk about, I know this course is focused more on geotechnical engineering, but the sustainability and resiliency is much broader and it has applicability in civil engineering. So I'm going to take a little bit higher level of presentation first. how sustainability and resiliency can be incorporated in civil engineering. Then I understand we will take a short break. And then I will focus on sustainability and resiliency frameworks and applications. So we talk a lot about sustainability and resiliency. Actually, I'm sick of listening to a lot of topics, a lot of presentations where they talk about sustainability and resiliency, what is their importance. But to me, what is important is how can I incorporate sustainability and resiliency? Walk the talk. How can I do something for sustainability and resiliency, not just talk about it and do something. So I'm going to show some applications in geotechnical and geoenvironmental engineering because this is the focus of this FDP. But all the things that I talk about, sustainability and resiliency, these frameworks, that can be applied in any field of civil engineering, and in fact, any engineering discipline. Then we'll have a short break. I'm so happy that we will have some time for discussion at the end. I encourage you to ask me questions. Any question is fine, and hopefully we can create that networking opportunity and get to know each other and create opportunities for future interactions. So this is the agenda. I have a time schedule here in terms of Chicago time and in terms of India time. I know for you it's very late in the night, but hopefully this is worth listening. So let's talk about what is the problem. Why are we talking about what is the importance of what the issues that we're talking about today. If you just take a step back and look at how are we doing civil engineering projects. It could be geotechnical project or even any engineering project. How do we generally do these projects? First of all, okay, you have a project in mind. First thing what we do is we look at the code and regulatory requirements. What are the codal and regulatory requirements, because you're obligated to comply with them, right? And then what we do is we do the technical design for safety. Let it be a design of building, or let it be a design of foundation or retaining wall or tunnel. So we do the analysis, and many of these analytical techniques, analysis techniques are established, and we teach our students design courses, and our students are good at doing the design. When it comes to practicality, we look at, hey, which kind of systems are easy to construct, and which one is going to be least expensive, and which one is faster to construct. So these are the things that we consider in all the projects. You talk to any engineers in practice, these are the things that they have in mind. Sometimes cost may be upfront in terms of considerations. Sometimes construction time, sometimes ease of construction, but no matter what, for the first two cannot be compromised, right? So, but anyway, we do this one. There's nothing wrong in doing this way. So this should be continued. But what we don't consider now is sustainability. We don't consider anything about sustainability in our current practice. And we don't consider anything about resiliency in our current practice. And we don't consider the life cycle thinking. And a lot of engineers, civil engineers, or even geotechnical engineers, they don't even know what these mean. I mean, they probably heard about the terms, but they really don't know enough to incorporate them in their design. So in fact, if you consider these additional factors, sustainability, resiliency, and life cycle thinking in any of our projects, let it be a geotechnical engineering project or civil engineering project or any engineering project, it can lead to very innovative solutions, and that are going to serve the function, but ultimately, they could even be economical. Most of the times they found to be economical. So why not consider? There is nothing to lose. We are going to only make our solution better and also save the money, right? So a lot of time in the business world, it's all about cost. But if you argue that cost is going to be lower, and then we're going to benefit a lot of these other things, then why not do it, right? And we have to do it. there is no way to get out of this, because this is the figure, if you can understand, on the x-axis is the Human Development Index. Anytime you have any country that has a Human Development Index more than 0.8 is called developed country. And then on y-axis, what I'm showing is the ecological footprint. All right. So I'm showing this dashed line. This is the biocapacity available per person by the planet Earth. So basically, if any damage happens, the Earth can recover back. So ideally, you wish you are a developed country, but without exceeding the biocapacity of the planet. So that means ideally you want to be in the sustainability quadrant, right? So what I'm showing these data points is for different countries, how they are in terms of Human Development Index and the ecological footprint. Look at the USA. USA is way high, right? It's more than 0.8. It's a developed country. But look at the ecological footprint. So the ecological footprint is very high. So the development has happened at the cost of ecological footprint. And look at Canada. Canada is here. So all these data points that you see here, they're all developed countries. They are all developed, but they didn't pay attention to the ecological footprint. And but a lot of this left side, you see all these developing countries, they want to be developed countries too, right? Everybody wants to be developed country because that's quality of life. But they are going in the same direction as these developed countries, which is not good. So ideally, we should be going into the sustainability quadrant. So we should be moving laterally into the sustainability quadrant instead of going like this. So that's not happening. I think the developing countries, which are developing a lot of infrastructure now, they can really, do differently than what developed countries have done. So the developed countries, did a lot of infrastructure. Now they are trying to fix it. They're trying to retrofit. When you build the infrastructure already and trying to make it, environmentally sustainable or, sustainable in general, that means it takes a lot of effort. But when you are constructing infrastructure new, you can start off with all the sustainable features and then make it more sustainable. It's very easy. So because we didn't pay, developed countries haven't really paid a lot of attention to the ecological footprint, we have caused a lot of ecological damage. In addition to that, we have depleted natural resources. So we were using natural resources like crazy. And then we created, waste, increased pollution in terms of soil, water, air, and the increased greenhouse gas emissions, climate change, leading to climate change. And then we ignored the sustainability in general when this development took place. So we don't want same things that we did and that caused all these problems to continue. So we need to do differently. So that's where the sustainability concept comes. What do we need? What do we need to do? So we need to consider the sustainability in our projects. So what is sustainability? I'm sure many of you heard about this as a word, and different definitions for this word. Okay, sometimes it's confusing, looking at the different definitions. But this is the definition that people use it a lot. This is the World Commission on Environment and Development report. It's titled "Our Common Future," and it's also known as Burnland report. Burnland she was the chair of this commission. So the definition is very brief and very powerful. What it says is the development that meets the needs of the present without compromising the ability of future generations to meet their own needs, right? Development that meets the needs of the present, us, right? I mean, we want to have a good quality of life. But however, whatever we do should not affect the future generations. So let's say, you use excessively and the future generations may not have it and they may not have the quality of life that you are having it. So this is a very powerful definition of sustainability, more philosophical definition. I like it, and everybody uses it, which is nice. So this makes you wonder, are we doing something that is worrisome? Okay, so why we need to worry about sustainability? I mean, we didn't worry about sustainability 10 years ago. All right, the sustainability concepts are becoming more and more, importance is gaining more and more these days compared to in the past. I don't know when all the participants went to school. Even when I went to school, I never heard about sustainability word in any of my courses that I took, right? But going into the future, we cannot really, afford to ignore the word sustainability. And it's very important for you to teach your students the importance of sustainability in everything that we do. So we need to worry about sustainability. From my perspective, the two big challenges. First challenge is global climate change and consequent extreme events. So the global climate change is due to increased greenhouse gases, and the greenhouse gases are basically carbon dioxide, methane, nitrous oxide, and a few other gases. Um, and because of that excessive release of those gases, you have climate change, global warming, and as a result, you're seeing all these impacts: sea level rise, floods, droughts, wildfires, and so forth. And people are, in the past, they didn't believe that climate change was happening. Now, people are experiencing all these strange events like excessive flooding that they never saw in their life, or never heard about happening in their area, and they are happening now, and the people started to believe this one. So all these extreme events, you see on the newspapers, you see on TV, it's happening in your area, it's happening all over India, it's happening all over the world. So now people recognize that this is in fact true, and we need to do something. So it is impacting current generations, the quality of life now, and it's going to impact quality of life of people. So we need to think about sustainability here. The other big concern is exploding population growth and consequent impacts. So world population just exceeded 8 billion, and it's going to keep on increasing, right? So if you have more people, more needs, right? More necessities. So that really, causes a lot of these problems: depletion of natural resources. Everybody wants a cell phone, right? And nobody will live without cell phone these days. So to make a cell phone, you need a lot of natural resources, and once we deplete those, we have limited quantity. So what are we going to do after that? And everybody wants to throw away the stuff, right? So more number of people means more waste generation, increased pollution, and we're going to have a damage to ecosystem, loss of biodiversity, urban sprawl. A lot of cities are, as you know, previously, they used to be in a small area. Now, you cannot distinguish between the main city and the suburbs. And there's a lot of economic disparities. Poor is still poor, and the rich is, becoming richer and richer. And so there is a lot of social injustice. So these are all the issues as a result of increased population. So this is not a theory, or this is not a fiction. Number of people, you can count it. It's a sensitive issue. No matter what you do, population is going to increase, and we're going to have these problems if we don't do things differently. So if we keep on doing the things same way that we have been doing, these are going to aggravate, and we're going to have more and more problems. So it's time for us to do something differently than what we have been doing. So I say these are the two grand challenges we are facing going into the future, and engineers have a major role in addressing these issues. In fact, if you look at it, if I plotted here the population growth and CO2 emissions, as the population grows, CO2 emissions are increasing. That means if I have to say one reason that we need to worry about is the world population growth. And climate change impacts are, are being witnessed now, and a lot of loss of life and property damage that's happening, affecting the environment. So these things are happening. Some places, these are not uniform, right? Some places is very dry. Some places, a lot of flooding, hurricanes, and tornadoes, ice melting, and then hunger, and air pollution, wildfires, and all these things are happening. So we cannot sit tight and say, okay, let these will go away. So the statistics, if you see them, these things are increasing every year. Okay, not decreasing. Every year they are increasing. So people are suffering. So now there is a call for action, and engineers can play a major role. Recognizing the sustainability is very important, and people wanted to do something at a global level. United Nations is doing a lot of things, and they developed this sustainable development goals. What should we aim for? Okay, we understand, sustainability is very important. So what is the roadmap, right? What are the things we should be doing to be on sustainable development path? So almost every student should know these things, about sustainable development goals. And in some parts of the world, they have a master's program and PhD programs on this particular topic itself, SDGs. But we need to teach our students, and we should be aware of the 17 goals. These goals are very broad, as you see. So first one is no poverty, zero hunger, good health and well-being, so forth. There are many things that are very, very directly relevant to civil engineering. So clean water and sanitation, sustainable cities and communities. That's life below water, life on. There are responsible consumption and production. There are certain things that are, we do daily basis in our civil engineering, but now, are we doing the right way? It's a time to think about how differently we can do it. So under each goal, there are some targets and there are indicators. It's not just the general topics. I see a lot of people just use this one for just talking about them, but actually there are specific targets and specific indicators that you should be looking at it and seeing how much your progress you are making under each of these goals. All SDGs are interlinked. So I see people, I am working on this, goal number 6, clean water and sanitation. But that means you haven't really understood this all SDGs, and they are interlinked. One leads to, cascading, positive impacts on other things. So you need to put all those things into the context, and then see how you are contributing. And as I said, role of civil engineers towards the sustainable development goals is very prominent, and we should be discussing these things. A lot of times we discuss about technical stuff, and we go to the classroom and, here is the theory, here is this. But I think we need to take a step back and look at it, tell the students, what are we going to achieve ultimately by doing, even though we are doing this small task per se, but how it could contribute in a larger scale. So that, I think, that will excite our new generations, because new generations, they don't have interest to listen to theories and example calculations and other things. So, but if you can give them bigger picture and excite them, I'm sure they will pay attention to the details that you're talking about. So this is in this SDGs. Number 13 is the climate action. So the climate action is about addressing the greenhouse gases and extreme events that we're talking about. All right. So this is very important to look at. So what can I do? So you are a civil engineer, or any engineer, right? Now, your education, you didn't learn anything. And you may think, oh, that's not civil engineering, that's not geotechnical engineering, that's not structural engineering. I'm not interested. So a lot of people, they think, it's not relevant, not interested, not my technical area or expertise, right? Oh yeah, this sustainability sounds good, but like when I look into the details, it's very complicated, and they think it's a global problem, and what they are doing is this has no relevance. But these are all wrong. So we cannot really, come up with excuses not do anything on sustainability. So that definition that we saw, the sustainability definition, it's very powerful, very succinct, as I said, but it does not help us in terms of doing something for sustainability. Let's say I want to do sustainability. What should I do? So in those cases, you have to look at the functional definition. There could be different functional definitions depending upon the field that you're dealing with. But in civil engineers, we regard AICTE as our prominent professional society. And they gave this functional definition of sustainability. So here, a set of environmental, economic, and social conditions that is called triple bottom line, in which all of society has the capacity and opportunity to maintain and improve its quality of life indefinitely without degrading the quantity, quality, or the availability of natural, economic, and social resources. So this is kind of a expanded definition of that Burnland Commission definition that I showed you before. So here, I mean, kind of essentially, the goals of this definition and the previous definition are the same, right? But here it's a little more descriptive, more prescriptive to do something about sustainability. So here, there's a triple bottom line. I redlined it. That's the important concept. So if we can consider anything that we are doing, if we consider the triple bottom line, what is the triple bottom line? Environmental conditions, economic conditions, social conditions. If we consider those things and try to maximize the positive impacts and reduce the negative impacts, then actually we are contributing towards the sustainability, right? So, but these triple bottom line aspects that you look at it, they are new to civil engineers. So, we don't deal so much about social conditions, we do the engineering cost estimate, but we don't look at economic, benefits and costs. And environmental aspects, we don't consider. If you are a structural engineer, you think, you have nothing to do with the environmental. Or if you are transportation, you think you know how to design the pavements and other things. You have nothing to do with environmental, right? But no matter who you are talking to, these environmental, economic, and social conditions have to be addressed in whatever they are designing. So let's say structural design of a bridge. Still you need to look at the environmental aspects. You still look at the economic aspects, social conditions. So this has become a challenge, to some of the older generation, because they haven't studied these things. But the younger generation, they like the concept of sustainability. They are adaptable, and they are willing to learn these additional things to add on to whatever the specialization they are in. So that's the one thing. So when we talk about sustainability, we're talking about the long-term conditions. But this climate resiliency, as I mentioned, the climate impacts are happening now, right? We need to cope up with these situations. There's extreme flooding. Tomorrow you have a lot of rain or sea level rise, whatever it is, surge. How do we cope up with these things, right? We don't want to have property loss of life all the time when we see these things. We don't know, when these things are going to happen, and it's expected to happen more and more, but you don't know when, So we need to be prepared for this one. So engineers, what they have to do is they have to consider the climate resiliency. What is climate resiliency? Whatever you are designing, ability to cope, adapt, and grow in the face of foreseeable climate and extreme weather impacts that may occur over the life cycle of the project. So we design based on whatever the course we have. But if there is some flooding or something happens, so you're going to compromise the performance. Hopefully, it doesn't collapse. And then, once the extreme event recedes, the performance gets back and then reaches to satisfactory level. Or sometimes you want to have it, increase the performance to the same level as before or even better than that. So this resilient engineering or design for resiliency is all about thinking about these extreme climate impacts upfront when you are designing it. Okay, you cannot really consider this high possibility of a very high extreme event. Then that becomes uneconomical, right? You don't want to, for example, even in earthquake seismic areas, you're not going to design for high seismic activity. You look at what is the possible scenarios there, and then you look at what is the design seismic conditions that you want to do it. Same thing here. You don't want to take about the worst case scenario because that may happen or may not happen. So you want to be able to consider the potential conditions there and then make a decision such that even if that happens, you're going to have a compromise in the performance, but you're not collapsing it. It's not you're not removing away the serviceability of the project, but then it's to be able to come back. So this kind of thinking is not there right now in our designs. So we need to think about sustainability. As I mentioned, sustainability is looking at those environmental, economic, and social aspects that will benefit the society, benefit the planet over a long period of time. But the climate resiliency is the immediate issue that needs to be addressed to avoid these extreme weather impacts. Obviously, if you practice the sustainability, you're going to reduce the greenhouse gases. And under the environmental aspects, you have to consider the greenhouse gases. So greenhouse gases reduction is reducing the climate impacts, right? Reducing the global warming impacts, and then ultimately this will go away. But for now, we are going to face these extreme events, and we need to be designing this one. So you need to understand. I mean, as I mentioned, when you hear the presentations on sustainability and resiliency, you understand the importance of sustainability and resiliency, but you don't get the main essence of what these really mean and what can be done. Sustainability is, as I mentioned, ensuring economic prosperity, protecting the ecological resources, enhancing the societal well-being. On the other hand, resiliency is the capacity for overcoming unexpected crisis, adapting to turbulent change, and flourishing in a chaotic world. The spelling there. So you need both of them. Okay, we need to have a sustainable design, and then during the extreme events, it's a resilient. And then if it is resilient, then you will keep on going in terms of the sustainability, right? But you design something thinking about long term and made it sustainable, and you didn't consider the resiliency, and when extreme event happens, that's not going to function. It's going to have a collapse. So sustainability is a long term, resiliency is a short term. And long term, short term, one time I said short term. Short term doesn't mean that it could be years and years. Okay. So it's short term doesn't mean it's a day or 2 days or year or 2 years. It could be decades. So that's we need to think about the difference between these two, and then we need to achieve both of them. So we need to we need to be thinking about these two. That's why I like to put sustainable and resilient engineering. So we need to be addressing these two things in our engineering practice. It doesn't matter what engineering you're dealing with. As I said, in civil engineering, we have different branches. We can do all these things. So in this one, first thing is about resiliency. So this is about what kind of exposure scenarios you have, and you do the vulnerability assessment, and then think about adaptive options, and select some measures and incorporate them, and then you need to keep on monitoring, because the climate impacts are not easily predictable. So then keep on analyzing it. It's like a constant evaluation of your system with changed climate conditions. So as a result of that, your designs have to be flexible to be able to make changes. So you need to think about right in the beginning that, hey, I have a retaining wall, or let's say a sea wall along the coastal area. I have current height is, let's say, whatever, 10 meters. If I need to increase another 2 meters, 3 meters, okay, it should be possible in the future. If you design now that only the fixed height, then you're not going to adapt to the future conditions. So you need to think about systems that are flexible, that can be changed. So that's all about resiliency. And then for sustainability is all about these triple bottom line aspects. You need to consider the environmental aspect, economic aspect, social aspects. Then other important thing is the life cycle. This is other important thing that civil engineers, even geotechnical engineers, don't understand it. What we need to think about is, any project that we are dealing with, we need to look at resource extraction, going back into mining, and then manufacturing of the materials that we use in our construction, transportation, and construction itself, and then maintenance, and then at the end of the life, you're not designing anything for perpetuity, right? So let's say it could be 50 years, 30 years, 100 years, whatever the design life that you have. At the end, what are you going to do? You're not going to be around to see that demolition, but future generations are going to be seeing that. So when they demolish, how much of it could be recycled? How much needs to go to landfill? So you want 100% to be recycled. So this is the life cycle concept. We need to think about it right up front in our projects. We don't do that one. If you think about this one, maybe we will use the different types of materials, different types of systems. So this is extremely important to look at. So this is, I call it, a sustainable and resilient engineering, is considering this adaptive design approach, right, in the for climate impacts, and sustainability, consider the broader environmental, economic, and social impacts, and considering the life cycle. So this whole thing is called life cycle sustainability assessment, or life cycle sustainable and resilient engineering. So I want to, let's say, yeah, I like all these things, I want to do it. So what are the things that I should be thinking about doing to be more resilient, more sustainable, right? So these are kind of like common sense ideas, or some things you need to keep in mind, some things you need to read more. So you want to incorporate renewable energy. The fossil fuels are the ones which are contributing to greenhouse gases, causing global climate change, all these impacts. You want to avoid as much as that. So think about your projects. Any project you think about, can I use the renewable energy? Ask that question. It could be solar, wind, geothermal, biomass, water, anything. Let's say you want to have a campus, you want to have a new building on your campus. How are you going to power it, right? So maybe you want to use these renewable energy sources compared to the conventional energy sources. And then materials perspective. Civil engineers, geotechnical engineers use a lot of materials. So now, instead of using the standard materials, ask these questions. Is there any substitute material for what I'm using? Or is the material that I'm using is green, or have a low carbon footprint, right? So embodied energy, how much energy is needed to make it, make that material, So what is the carbon footprint associated with that? And then we should also think about water footprint or integrated water management. I think a lot of things in civil engineering has to do with some water, right? So you need to think about how do you manage that water, and how do we reduce the consumption of any water in our projects. And then waste management, integrated waste management. So anywhere, anytime we generate the waste, if we don't handle that one properly, we're going to have issues. So this is called circular economy, putting the material back into the use all the time, not have to dispose. So that's kind of a system that we need to think about it. And then think about the nature. Mother nature is so powerful, you cannot really go against it. And nature-based solutions are mostly resilient and sustainable. So there are many advantages of using the nature-based solutions. But the problem is that not many civil engineers, not many geotechnical engineers understand how to select and design these systems. So there's a knowledge gap, and obviously some of the things that you are doing are new, and you will develop the new knowledge later on. But it's very important to understand, and work with multidisciplinary teams. Let's say if I want to have a park, then you have to work with the ecologists and other people. So it's very important to look at that one. And as I said, sustainability is being practiced, and especially in the universities, they want to be they don't want to teach the students, but they want to be role models for the students. Hey, look at the campus, we are doing the sustainability, and you should be thinking about sustainability as you go into the future. So I'm showing this is my campus, and these 3 buildings, as I said, in US we have built infrastructure. So these are the old buildings that have been remodeled completely, and we have a geothermal system that provides the energy, and you have a solar, and there is a stormwater control system. So there are many green features incorporated into this one. So we tell our students, hey, we not only teach, but we practice on campus. So you can look at go to my website, university website, and look at all the sustainability initiatives that we have on campus. And then this is an example of what sustainable resilient engineering is, using this nature-based solutions. So here is the, for example, you have a coastal wall, let's say along the coastal area, you have a surge. So this is the concrete sea wall that we use, right? This is the kind of now the practice is that. But going into the future, as I said, like how much is the surge, how much is the sea level rise, you cannot predict it. So the adequacy of this seawall is questionable. So now what we're thinking about is this floodable park. So basically you create the buffer zone. You don't want to have any infrastructure within the buffer zone, and you have this vegetation that is properly selected. And let's say if the surge is high, okay, the park gets flooded, and these plants and other things are resistant to those changes. And then when it recedes, you have a park. And this has been used a lot of places. This is in New York, and this is the coastal area. And instead of building that concrete wall, see these parks, obviously this kind of elevation goes up as you go in a little bit inland side. And when you don't have any impacts, then park is beautiful, people can use it. And if there is a surge or hurricane, people will run away to their homes, and this whole park is going to be getting flooded. But then when it recedes, the park is back to normal, and life will go on. So this is kind of systems that we're looking at. This nature-based solutions are becoming more and more important in US and even other countries. So you need to think about, okay, if I'm going to have a flooding, how I'm going to handle this excess water. There's a sponge cities concept. And so here is, especially in urban areas, when it rains, where does the water go, right? So a lot of times it becomes a runoff, and then it floods the area. So this is in Netherlands. So this is in the middle of the street. So what they did is they created this park, but the concept behind is as you see here, it's a depression, right? So it stores the water. It's like a temporary storage of the stormwater. When it rains, this whole this park playground area is going. It's like works like a reservoir, and then it stores there, and then then you can handle that one, discharge it slowly. So this kind of nice benches, and this one, so it serves the dual purposes, for leisure as well as stormwater storage. And in the building industry, there are many innovations that are happening. Vertical forests, having the vegetation on the buildings, that has a lot of implications. And going into the future, a lot of people are going to migrate to urban areas, and you need to have these buildings And the buildings that we are having now, they may not be serving the function. So going into the future, we're going to have a multi-story buildings with a lot of urban farming within the buildings itself. So that's kind of a concept that's coming up. The other thing that I want to mention is the smart technologies. So don't think that civil engineering is an old field, students are not interested, but we need to teach our students on use of smart technologies in our field. So all these technologies can be used to make our civil infrastructure smart. And then we should also think about sustainability and resiliency along with that smartness. So just don't look for, putting the sensors and making it smart, but if the whole system is not sustainable and resilient, then you're not doing good things. So this can be done in every field of civil engineering, including the geotechnical system. So, but future, a lot of things are going to happen. I mean, just if you close your eyes and think about future, things are going to evolve very, very rapidly. We're going to think about alternative energy sources, autonomous vehicles. You already know that one. That will change the entire civil engineering field, including transportation, especially climate change, smart cities, high-tech construction and advanced materials, and the policy funding. How the policies are developed and funding is provided. That's going to shift towards all different way of doing civil infrastructure, a different way of doing geotechnical engineering. So we need to prepare civil engineers for these new challenges. All right, so resilience for extreme environments and anticipate changes in demographics and urbanization. And then we need to incorporate materials, the new materials that are being developed all the time, and computing power technologies, engineering construction processes, the digital models and big data use, digital security, intelligent systems, autonomy and virtual reality. Understand the system dynamics and nature of systems engineering and systems integration. So we should not be looking at things in parts. We should look at the holistic way how the system is going to perform. And we need to innovate. I mean, doing things same way is not going to work. We need to innovate, to find new ways to do it. We need to also think about risk management, and ethics is extremely important in all these aspects. And we need to be collaborating with other people, and we need to come out of our silos. So especially in engineering disciplines, even civil engineering, so geotechs are one section, structures is one section, and all those things. I think those silos will have to come out, and we need to collaborate with each other. And then moreover, we need to collaborate with non-engineering partners. For example, if I'm talking about social issues, broader economic issues, we need to be thinking about non-engineering specialties. So I'm sure you will find a lot of people on campus or in other universities that you can collaborate with. And when you integrate those other aspects, it's so satisfying, the impact that your project is having, and you feel good about it. And again, we need to attract new talent, continuously train and grow careers. On the educational front, because we have a lot of faculty taking this course, so I just want to mention that all engineering students must acquire the knowledge and skills needed to promote sustainable development. This is the need of the hour. And in US, we have ABET requirements, right, for undergraduate accreditation. And that this is specifically mentioned that we should be teaching our students sustainability and sustainable designs. And then we need to, make our curriculum a little bit broader, just not too much focus on, civil, or geotech, but, kind of give the options, broaden up their background into, environmental, economic, social, societal issues and other things. And then, of course, whatever you learn in school, in their degree program is not enough, because, things are rapidly changing. Even, when I teach a course on sustainable engineering, every time I teach, my content is totally different, because things are evolving and we need to be lifelong learners. And we need to tell those people, I mean, even as a faculty, we need to be learning, and we should be telling the students about that one. And we should tell the students that whatever they learned in the classroom in their college is not enough, and they need to keep on learning. So these are the things that we need to mention. So this is the book that I would mention. You should get hold of it and read it. It's very simple to read. So and then what I want to do is, I want to take a break here. I know I've been talking for some time, and I will suggest that we take some break, and then come back and continue. How do we do, in real practice? I want to talk about frameworks and then some examples on how we can apply the frameworks for sustainable and resilient designs. Can we take a break? Well, let's say,
Yes, sir. Thank you for the session part 1. It was a eye-opener to learn a lot of things about sustainability in basic civil engineering challenges based by not only the society but specifically for the educationists. Let us have a couple of minutes break before we continue the session. Thank you, sir.
So what time is in India now?
Yes, sir. We can continue the session at 8:30 p.m. IST, 8 minutes from now.
Okay, that's good.
Thank you, sir.